The views and opinions expressed on Coffee and Compatibility are those of the podcast host and do not necessarily reflect the official policy or position of ASHI.
Welcome, everybody. Today on Coffee and Compatibility, we have a most special episode. We are so honored to welcome Mr. Ricardo Ordonez, president of the Terasaki Innovation Center. The Terasaki Innovation Center continues the legacy of Dr. Paul Terasaki, whose groundbreaking contributions transformed histocompatibility testing, transplant immunology, and HLA science as we know it. Thank you so much for being with us today. In honor, I would normally ask you if we could call you Ricardo, but in honor of your dear friendship with our past ASHI president, Dr. Kathy Murphy, I will ask you if we can call you Ricky.
You certainly can. Absolutely.
So exciting. Oh, I cannot tell you how much excitement there was that you accepted this invitation. This is the first in the series that we hope to do throughout the year in reintroducing some of the founding forefathers of our field and our science to the broader HLA community, bringing more knowledge about these people to the younger generations of histocompatibility practitioners, and what better way to start than by talking about the life of the Dr. Paul Terasaki. And I can't think of anyone who knows Dr. Terasaki better than Ricky. So I was thrilled that you accepted our invitation. So I would like to start by acquainting the audience with how you came to know Dr. Terasaki and what your relationship was like in those early years.
Yes, okay. So first of all, thank you so much for the invitation. I think this is a great honor to talk about my mentor. But first, to your initial point, I just wanted to say that I think it's great that you guys are focusing on some of these pioneers, because in the last couple of years at the ASHI National Meeting, as well as going to FB, I met a lot of young technologists. And to my surprise, they have no idea who Paul Terasaki is, nor what his contributions were to the field. In fact, I remember one young lady in the FE meeting in Prague last year, when I was introduced to her, she said, "Oh, he's the one that invented that little cute tray." And I go, "Yeah, he's the one that invented the little cute tray." So, but it's not their fault because they've never been introduced to any serological testing or anything like that. So they don't know who he is or what he did. They just know that there are a bunch of awards after his name. So, but this is a great opportunity to start that sort of re-education of some of these pioneers. So going back to your original question, so I went to UCLA. In my second year at UCLA, I realized that I needed to go get a job to make money. And my roommate at the time, she was working in the laboratory, but in the administrative section of the lab. At that point, the lab was a very large lab. And she told me, you should go apply to the lab because they're hiring students. And I said, well, I'm not a science major. They'll never hire me. And she goes, oh, it doesn't matter. It doesn't matter. They'll hire you anyway. I was a communication/linguistics major at UCLA. So I went to my first interview. I was interviewed by John McClellan, and John was Terasaki's very first technologist, and he appears as the co-author of the microtest from 1964. So John interviewed me, and he basically asked me two questions. He asked me, number one is, what is your major? Number two is, can you start on Monday? And what was interesting about that interview is that when I think about it, and I realized what happened that day, it is the only job interview I ever had in my entire professional career. I never had another job interview. So it was fairly easy. But that's how I got to work in the laboratory. I started working, doing some not so pleasant work. I was actually extracting fluid from placentas because they had determined that multiparous women carried great antibodies, and so we were looking for those antibodies. And I was working with Stuart Hahn at the time. He and I were the placenta guys at the time, and people who know that story make fun of me all the time about placenta work at UCLA.
So Ricky, we have to ask you, we have to kick off with this, right? He's best known for the invention of the microcytotoxicity test. We
Right.
have to ask you about that. What about the work leading up to that test? And I just recently learned, right, that he invented this when he was 35 years old.
Yeah.
And that made me feel like I'm behind. I don't know
So
about some other
if you don't,
people, but
I will get to that, but if you don't mind, I just wanted to talk a little bit about his childhood because
yeah, please.
it was a little complicated. I will definitely cover it because that's a very, very critical part of his life. But I think it's important for people to understand what he went through as a, as a child growing up in Los Angeles. He was born in LA in September of 1929 to a father who was born in Japan, to a mother who was also Japanese, but she was born in Hawaii. And they were, I think they were living the typical American dream. They had bought a house, they had a small business, they had three sons who had gone to school, but everything came to a screeching halt when the United States declared war on Japan after the bombing of Pearl Harbor. So 2 months after that incident in Pearl Harbor, President Roosevelt issued an executive order, I think it was 9066, obligating every American of Japanese descent to report to a relocation camp. And that family lived in a one-room barrack from 1942 to 1945. And they lived in Gila River Bend, which is a little bit south of Phoenix. So after the war was over, the family did not want to go back to Los Angeles because of the anti-Japanese sentiment. So they moved to Chicago. And that's where he graduated from high school. He graduated from Hyde Park High School in Chicago. After high school, he went and became a pre-med student at the University of Illinois at Navy Pier. I've never heard of that campus, but that's where he went to school. And he lasted there for about 2 years. And then in 1948, the family couldn't tolerate the cold weather anymore in Chicago, so they came to they came back to Los Angeles, where he enrolled at UCLA. He got his bachelor's, his master's, and his PhD in zoology from UCLA. So while he was working on his PhD, he went to work for the Department of Surgery. And his first research project was to study skin graft transplants on newborn chicks. Um, so he got his PhD, he got married, he had two kids, he was working on this project, and then he realized that UCLA was really far behind in this research when he read a paper that was published by Peter Medawar, because Peter Medawar had successfully performed skin graft transplants on mice. So that inspired him to want to go work for Peter Medawar. Peter Medawar became his scientific mentor because he worked under him for a year. He went to London with his wife and his two kids to work for Peter Medawar, and he stopped working on chick embryos and started focusing more on human cells, learning how to do different cell isolation techniques and so forth. And towards the end of that year with Peter Medawar, he came across an interesting article written by Jean Dassé called leukoagglutinating antibodies. So then he wanted to go work for Jean Dassé. So he wrote to his department chair, Dr. William Longmire, and asked him if he could extend his year in Europe to go work with Jean Dassé in Paris. He said yes. So he wrote to Jean Dassé, asking him if he can come and work for him in his lab. And the interesting part of that story is that all of the communication between the two of them was in French. And what's interesting is I never knew that Paul Terasaki spoke French, But he got to Paris, he got to Dassé's lab. They had an interview. Dassé spoke to him fully in French. He didn't understand a word Dassé said. And Dassé realized that he really didn't speak French, and he rescinded the invitation. And that basically, he sort of gave up on the fact that he was going to work in Paris, and he returned to Los Angeles and went back to UCLA to focus to work more on cells and antibody work. He didn't quite like the agglutination test that Dassé was doing because he didn't think it was reliable, and the volume of reagents that were needed was way, way too high. And that's when he decided that he needed to develop a technology using less reagents. And as we know, that's how he figured out that at 1 microliter, these reactions could happen, it could work. But he faced a lot of challenges with that micro test. He spent many, many hours trying to put it together. The first challenge of the micro test was, at such low volume, how do you prevent dehydration? And so he discovered that mineral oil was the answer to that question. The second challenge was, how do you dispense such a small volume of reagents? And someone introduced him to a company by the name of Hamilton, and then that created the Hamilton syringes that, sold by the thousands afterwards. And the third part was how to read the reactions on this microtest. And he remembered, he first of all, he realized that it had to be an inverted process. And he remembered that Peter Medawar had an inverted Zeiss microscope in his laboratory, and he was able to get one as well and realized that it worked pretty good. Now, keep in mind that during this time, the tray, the actual physical platform, had not been invented yet. So he used a glass slide surrounded by aluminum foil. But that became a little bit too messy for him. And so he started to figure out what other things he can use. And he actually started to play with some of his child's toys and started to put together, he actually put together this sort of plastic platform that he could use for the testing of the tray. But eventually in 1967, he worked with a company called Falcon Plastics, and they developed the 60-well Terasaki tray. So that's how sort of that came to fruition. In 1964, at the first international workshop in Durham, that's where he demonstrated his test to the other pioneers. It wasn't that successful. There were other 8 cytotoxic technologies that were being introduced. Not everybody, not all the pioneers were convinced except for one. Ricardo Ceppolini from Torino, Italy, was the first one to think that Terasaki was onto something, and actually sort of sided with him on this is the way to go, although the others did not agree with him in 1964. And in fact, Ceppolini invited Terasaki to go to Torino to demonstrate this technology to his lab. And that it was such a big event that it actually made the front page of the Torino newspaper. I think Effie has a picture of that newspaper, this whole demonstration process. But it took a while for him to actually convince people that this was the technology to use. And it wasn't until 1970 when he was asked to host the 4th International Workshop in Los Angeles, and he agreed to do it under one condition, that every lab involved in the workshop would use his microtest to test the serum samples that they would be receiving for the workshop.
Wow. I want to say thank you for sharing that background with us. For me, and I'm sure for a lot of people listening, the value to this is that I have always seen Dr. Terasaki as, this brilliant figure that just got it right and did something that changed our field forever. And that is true. But what I'm learning from you is that course and that path was not linear. And there was a lot of trial and tribulation and proving himself. And that's got to be valuable, because don't we all experience that and have a lot of issue, but he persisted.
Yeah. Yeah. It's interesting, a couple of years ago, we had at the 50th anniversary of his seminal paper on cross-matching, there was a symposium here in Los Angeles for him. And I forget his name. He's a surgeon at Duke University. The keynote speaker. So he made a comment. He said, if you think about what Paul Terasaki did, especially when he invented that tray, in today's world, everybody talks about personalized medicine, and everybody does. But actually, Terasaki was the first to introduce personalized medicine with this test, back in 1964, So yeah, he was very progressive thinking, forward thinking. He basically thought very far in advance of what could possibly happen with what he was doing.
I think this is fascinating because there's so many little nuggets that I don't think the average person knows, right? Like, who knew that he could speak French? And so
he couldn't speak French. That was the thing. He did
right, but that they were corresponding that way, right?
Yeah, he got someone to write letters for him.
The genius move behind working with Hamilton and Falcon, who are like major, entities to bring something like this to fruition, right? It shows the complexity of taking something as simple as let me work on a microcytotoxicity test and then like how you build it out. And so,
Right.
it brings me to the idea of, given all of your experiences with him, are there particular moments that stick out to you as, sort of favorable moments of interacting with him and his colleagues and, your just experience with him?
So, um, you know, working with him, I just remember every time I went and spoke to him about a project or something that I wanted to do, and this is when we had already formed One Lambda. Um, he told me once that, Medawar, the year that he spent with Medawar was the most significant time that he had ever spent in his scientific career. And he said, I'm going to ask you questions, that Medawar would ask me about what I was doing. And for example, Medawar would say, what important question does your research answer? He would put Terasaki in that, in that position. So with me, he would basically do the same thing and say, you know, what you're proposing to me, why is this important? Always asking me to, or questioning myself, expecting me to know exactly the reason why I was doing what I wanted to do. He was very, very demanding as a scientist. He was very humble, but yet very demanding with his employees and always questioning the things that you were doing and why you were doing them. Um,
So, Ricky, could you tell us, you mentioned there One Lambda.
yeah.
Could you just tell us how that came about, right? How that chapter of his life came to be?
Well, that's an interesting chapter. It's a little bit convoluted because if when Lambda was formed in 1984. But if you think about the history of that, it really begins in the 1970s when the NIH provided Terasaki with a grant to manufacture trays and distribute them to labs in the US for free, which he did. Then he went to a meeting in Holland and presented a very controversial paper. And in that paper, he said, we find that our mismatched patients are doing as well as our matched patients. And the NIH got hold of this and said, wait a minute, you were telling us that people had to be matched or else if they weren't, they would reject. And now you're saying that they can be mismatched and it doesn't matter if they're really matched or not. So what they did is they took away his grant, which cut about 80% of his research. But he was still a firm believer that HLA testing and compatibility testing was important, as were some of the transplant immunologists that he was working with around the nation in their labs. So he decided to sell or to manufacture and sell his trays directly from his lab. And he was selling those trays for $15 a tray. He did that for 14 or 15 years. But at the end, around 1983, the whole process of manufacturing and selling trays wasn't very regulated. So you saw these commercial companies started to emerge and start selling trays. Companies like Biotest, companies like Pelfreeze, Gentrack, etc. One of those companies actually wrote to the UCLA chancellor and said that there was a disadvantage because the Terasaki lab was selling trays and they didn't have to pay tax because they were a state university. So then they gave Terasaki an ultimatum. They said basically, you either dismantle the tray manufacturing process or you take it outside. Now, at that time, the gentleman who served as CEO of One Lambda for 28 years, his name is George Ayub. George had gotten his MBA, but he actually put together the business plan to put together One Lambda. And he presented it to Terasaki and it was accepted. And so in 1984, on April 1st, the One Lambda started the business. So that's how we created that business. And HLA was kind of in its infancy. I recently reached out to Stephen Marsh to ask. I didn't remember exactly how many HLA antigens had been defined by then. It was kind of like 100 or so. So it was class 2 was at its total infancy at that point. But when we started the company, our biggest challenge was First of all, the lab, there was 200 people in that lab that were working with Terasaki during the train manufacturing process. When we started the lab, he only selected 7 of us. I was fortunate to be one of the 7, but I always tell people that I was one of the 7 because I was cheap labor, So I was working from a student salary, so I wasn't that expensive to have. But we as a company initially we faced a lot of challenges because we had really no business experience, but we did have a lot of understanding and knowledge of HLA testing, which was really important to the labs that we visited. And the biggest challenge for labs is that they were trying to implement class 2 typing. So the whole technique of separating T and B cells from whole lymphocytes was a challenge for them. So we went to these labs to train them how to do that, so they could start buying the class 2 trays from us. So that's how it all started.
Wow. I think it's such a legacy of work, and so it's so clear that that Dr. Terasaki didn't just change transplantation forever through the microcytotoxicity test.
No,
He changed it in a variety of scientific
right,
ways, working
correct.
with lots of innovative partners, kind of setting a legacy for, provision of diagnostic tools. And so I'm really interested to ask you, do you feel like Dr. Terasaki, before his passing, ever really retired? And I ask that full well knowing that with the formation of the Terasaki Institute, that can't possibly be true. But I want to hear the facts from
No,
you.
he never retired, and in fact, while he was on dialysis, he was still going to the foundation. I mean, I think, even a week before he passed, he was still going to the foundation. He never really, really retired. I mean, this was his love, this is what he lived for. But you're right, he did so many things. You can talk about, for example, the CDC cross-match test, in 1969. I mean, that pretty much revolutionized the field of transplantation at that time. You can talk about at One Lambda, under the development of Dr. Jar Hali when he introduced a single antigen bead. I mean, he spent years and decades trying to convince clinicians that antibodies played a huge role in rejection, but they sort of ignored them because there wasn't a real significant tool for them to use until that single antigen bead technology came into play. Then all of a sudden, you went to an ATC meeting, everybody was talking about MFI values. You talk about the Collins solution, that a solution that he developed with Jeffrey Collins for cold storage for the shipment of kidneys, and what the impact that had, and you talk about the UCLA cell exchange, the proficiency test. He discovered a solution that kept cells viable for 2 weeks, and created the cell exchange involving 300 labs and sending unknown cells to people for them to type and send the answers back to him, and publishing those the following month. You talk about the registry, the UCLA registry, which he started in 1970 to study transplant outcomes. He reached out to certain centers and said, would you send me information about your patients? I want to know more things about the matching data, the age, the race, the gender, the kidney size, etc. This is a wealth of information for him to use. And 17 years later, in 1987, the U.S. decides to establish the UNOS registry, collecting data from centers all over the U.S. So yeah, the impact was monumental for the field.
I think the scale of which the impact, and so the audience knows, many of these things are still being used,
Yeah,
like current day, right? We're not just talking about things that were in the 70s and now in 2026, we're not doing that. Like
right.
many of them are
They've been
still active.
modernized. Yeah.
Yeah. We're still using them. So that's a substantial reach, right? Of cross, decades. And I think with the start and use of the foundation, do you want to touch on, what the foundation is doing now to continue on the legacy?
So I should clarify to you guys and to the audience is that there are actually 2 Terasaki organizations, right? So he started the Terasaki Foundation, his own foundation, in 1999 when he was forced to retire from UCLA. And I underlined the word forced because he did not want to leave the lab in 1999. So he started his foundation to continue his work in transplant immunology, right? So after he passed away, the family decided to sort of reorganize the foundation to bring in more different areas in medicine. So today, the foundation is now called the Terasaki Institute for Biomedical Innovation. And they cover things. They talk about or do research on personalized cells, stem cell engineering. They look at devices, both sensors and theranostics. They do personalized implants. They're doing work on organ-on-a-chip technology. So they're doing many different things under many different circumstances with different scientists. His older son, Mark Terasaki, who is a professor at the University of Connecticut, he decided that he wanted to make sure that there was an organization that continued his father's research in transplant immunology. So he formed our organization, the Terasaki Innovation Center, which he asked me when I retired from One Lambda, he asked me if I would run that organization. And we have three courses. We're a very small organization. We have three scientists. We have Jarhal Lee, as you know. We have a PhD by the name of Remy Shi and Toa Nong. And these three individuals were part of the research organization at One Lambda. Then the three of them left to form Tau for this. And we're doing more of the convention of the traditional research in transplant immunology. We've published papers on DQ antibodies, class 1 peptide polymorphisms, just different areas of that particular field.
Well, Ricky, I want to close by asking you how you feel Dr. Terasaki impacted your life.
Oh, my life.
Clearly, he's impacted the lives of so many people, so many people that will never have met him, so many people that are working in the field today that, thank goodness, thanks to your participation in this podcast, maybe feel a little closer to the man and the scientist that he was. What is his lasting legacy for you?
Wow. That's a hard question because there's so many things that he impacted me. Because I was with him for 40 years. So he taught me to, one, question what I did and make sure that I knew why I was doing what I was doing. The relationship thing to me was interesting because as a scientist, I noticed that he, when he and I and we would be at meetings, there were people that he just didn't agree with scientifically. And there were other scientists that didn't agree with him. But when they got together, there was this sort of scientific mutual respect for one another. And I just, I always honed in on that particular part of him. And I thought, well, that's interesting that, I thought you guys hated each other, but at the end of the day, they just respected each other as scientists. He taught me how to continue to be organized in what I was doing, because he always questioned me about things. I organized a lot of scientific meetings for him and workshops and so forth that I think you have participated in some of them today that carry on from him. Always wanting me to make sure that the program included diverse opinions of different topics, whether it was cross-matching or matching or what have you. So just there were so many different things that he had an impact on me, and I am where I am today because of him. That's without question.
Thank you so much for being with us today and for sharing this important life story, this important scientific story. It's an amazing and diverse one, and I think to the benefit of our group. And thank you so much for all that you and Dr. Terasaki definitely did, and that you continue to do to support the ASHI community and histocompatibility and immunogenetics. It means so much to so many.
Yeah, you're welcome. I look forward to the next meeting. I was just saying earlier that my first ASHI meeting was in 1985. I'm sorry, 84 in Miami, Florida. And I have been to every national meeting since then, 41 of them to be exact. So that
That's
just
got to
tells
be
you,
the record.
yeah, that just tells you that I'm old. So so thank you guys for this opportunity.
Absolutely, sir. Thank you very much.
Thank you.
Thank you so
Okay,
much.
thanks.
Put your research in the spotlight when you submit your manuscript to Human Immunology, ASHI's scientific journal. Authors will enjoy an enhanced submission experience with a streamlined, intuitive, and accessible interface. Plus, each monthly journal cover will feature a figure from a manuscript published in that issue. Submit today and let your research take center stage. Visit submit.elsevier.com/HIM. That's submit.elsevier.com/HIM.
Okay, welcome back, everyone, for the tea, the part of the show where we answer questions from our audience. And today's question is, HLA Beyond Tears was standard reading for HLA technologists for many years, but the second edition was published more than 25 years ago. At this point, what do you all think is the best textbook or resource from which to learn HLA?
Ooh-wee, that's a doozer. So it is also older, although I think there is a newer within at least like the last 5 years version. I could be lying. Oh, public. I will accept correction if I'm wrong about this. But one that I loved while I was training, and I always share with my trainees, is something called Histocompatibility and Immunogenetics by Delordes and Cologne. A collection. It's called a collection of brief revision notes, which I've always found so funny because that is not at all what it is. It's like over 200 pages long. It is very detailed. I felt like for me, it really disseminated the information well. It was very readable. And it's a great reference for like disease association and drug hypersensitivity, and it just covers HLA from so many angles, from more basic science, didactic, to more clinical application. I love it, and like I said, I think the version that I loved when I was a fellow was put forth in 2011. But I want to say there is a new version of it that came out within the last handful of years. Highly recommend it. I don't know. Other than that, there's just like, the literature. Just keep up with the literature and some historic documentation. Eric, do you have any that you particularly adore?
No, see, I feel like I hear this question and I'm like, I don't really have a particular one that stands out. My opinion would have been what you said, right? Sort of current reviews, literature reviews, I think are always pretty useful way to learn what's going on, especially, with some of the articles that come out. But nothing stands out beyond what you said.
Yeah, part of what I love about this question is this is actually a very common question. So I know that a lot of folks, myself included, we have residents that come through the lab. We have CLS students that come through the lab. We are actively teaching people, maybe that are not directly in our specialty, about histocompatibility and immunogenetics. And from a student perspective, one of the most common questions I have is like, is there just like a textbook that you can refer me to? And I think all of us know that's just such a funny question, because inevitably you're going to be like, well, there's that one. but it is written quite a while ago. So audience, I would love to call you out on this. Share with us your favorite HLA reference material that's broad about histocompatibility and immunogenetics, be it a textbook, be it any type of reference or review that you particularly love. If you have one that we did not mention, which pretty much just consisted of HLA Beyond Tears and histocompatibility and immunogenetics, a brief revision of notes, shout it out. Please email us. And along with that, if you need career advice or have a question about something happening in your lab or department, visit our podcast page, ashi-hla.org/page/Ashi podcast. podcast, or email us at info@ashi-hla.org with the T in the subject line. And, along with that career advice, send in those references. We'd love to have them, and we'd love to share them with the listenership. I think they'd really benefit from it.
Now it's time for Tech Talk. Today we're spotlighting David Eskendry, an expert medical laboratory scientist advanced at the UPMC Pittsburgh Histocompatibility Lab. David is recognized as an exceptional scientist and role model in his laboratory, consistently exceeding standards in quality, safety, and HLA result integrity. He serves as the HLA Lab Quality and Safety Officer, helping ensure inspection readiness and compliance with organizations including UPMC Lab Services, CAP, ASHI, and others. David also serves as an HLA Lab peer group leader, assisting with scheduling, interviews, and evaluating prospective hires. David is an enthusiastic promoter of ASHI, holds his CHT certification, and hopes to achieve CHS certification in the future. David would like to acknowledge that his HLA career contributions would not be possible without the teaching, training, and support from Dr. Adriana Zevi, Dr. Q Yu, Manager Betty Hunter, Lead Nina Baumgardner, Lead Dennis Helmick, Lead Kurt Johnson, Lead John Lamago, Lead John Sadowski, Senior Administrative Assistant Monica Green, and Bioinformatics Scientist Mitchell Ellison and his UPMC lab coworkers. David, thank you for your dedication, leadership, and commitment to excellence in histocompatibility and immunogenetics.
Okay.
If you'd like to nominate a technologist for spotlight recognition, please email info@ashi-hla.org with their story and why they deserve to be featured on the next Tech Talk. All right, what an incredible discussion with Ricardo Ordonez about the legacy of Dr. Paul Terasaki and how his influence continues to shape transplant immunology today. Guys, what do you think of the interview?
It's such a big story. I think there's so much in there. We know about the microcytotoxicity test, but that was like far from the only thing that Dr. Terasaki was touching. And the personal things, what his family went through in World War II, how much personal adversity he overcame, how many different amazing scientists he got to work with, how much he had to move around and experience to accomplish what he accomplished. The fact that at the end of his life, he was on dialysis. There's so much to unpack that we couldn't even, we just scratched the surface today, but I hope it gives people a great appreciation for the person that he was and the scientist that he was.
And something that stands out to me is like not just the adversity he's gone through, but we talk about some of these sort of legends of our field, if you will, as though like they never really did anything wrong, right? Or got something wrong, or right. And I think the fact that you get knocked down and you still overcome the adversity and you keep believing in what you believe in, and figuring out ways to work across differences and to grow something from like its literal invention, right? To find how you're going to make the plastics, how you're going to transfer the liquids that are that small, right? Like these are things we take for granted today. Highlight that it's never solely one, right? Like it takes a village and a team of scientific and medical innovation to make something truly transformative. And, to have the push to do those, generally requires one person who believes like to their core, right? And, to me, that's one of the take homes from hearing about the life.
Yeah, I really enjoyed, like Kelly said, the personal things, the personal details that Ricky shared with us were really meaningful to me. I'm a history buff, and so I really appreciated hearing about his background and what he overcame. Is really inspiring, and how much he accomplished at a very young age was really inspiring as well. And I hope it is to other people. I feel like we do have to answer. Ricky mentioned that there was someone who asked Is he the inventor of those cute little trays? We have to answer that question. Yes, he was the inventor of those cute little trays, but that's the understatement of the century. I really enjoyed hearing Ricky lay out for us. Not only did he invent those micro trays, but went on to accomplish a whole lot more beyond just that micro cytotoxicity test.
Yeah, I think it can't be stated enough that this is a legacy that continues through the Innovation Center, through the foundations. He and his people must have had a fantastic eye for talent, because to this day, the student that he found, Ricardo Ordonez, is still supporting this science, doing this amazing work through this legacy, helping ASHI grow, helping our membership continue to innovate and be thoughtful and be present. Mark Terasaki, Dr. Terasaki's son, is building a legacy and a science craft of his own. So it continues on in ways that are so important to our field.
Yeah, and I think that's the beauty of the story, right? Is that it's not over, that it continues to go. So,
speaking of it not being over, this is a terrible transition. I'm just going to put it out there. We've had some questions from some listeners come in about continuing education credits. The education also continues through this podcast. So yes, there are new 2026 ASHI continuing education credits and a code that'll be released for this episode. So visit the Coffee and Compatibility podcast page on the ASHI website, where the current continuing education code and participation instructions are posted.
Well, this has been fantastic.
Yeah.
Until next time, guys. Bye.